Hey everyone, how's it going? It's been a while. I recently started my fucking summer project from a master's class, and I currently find myself working for a neurology laboratory. Oh, my water's boiled. Let me pour some tea. And yeah, so I just started a week ago. I'm getting to grips with it, and basically the company took me on, and yeah, I'm basically tagging along with their little project here. And my supervisor has given me several papers to read over. It's quite a few papers, but it's a couple less than what I thought. Because at the beginning, I thought I had like fucking 10 fucking scientific journals to read through. But turns out I only have 8 to read through, which is a bit of a relief. And part of this project is that I have to do self-reflection and also submit another report of the project I'm currently taking on. So that's 2 things I need to submit over the next couple of months. But yeah, it's been alright so far. So like I said, I'm working at a neurology lab, and all I'm doing right now is staining slides, which doesn't take very long. It's like working a part-time job, except I don't get paid. So yeah, I'm just in the lab for like 5 hours, and then I just fuck off to do whatever the fuck I want to do. But essentially, during that time that I'm away from the lab, I'm expected to do shit for this, these fucking reports I have to write. So, like I said, my supervisor has given me papers. I'm gonna read through them. It's probably gonna be very dry. This is going to be a very dry stream, unless someone keeps me company and, I don't know, distracts me or something. I might take a break to fuck about a bit, because if I do nothing but this all the time, I'm just powering through all of this, I'm just gonna fucking... My mind is just gonna be absolutely fucking numb, and I wouldn't be able to do anything. So, every now and again, I'm gonna take a break. As you should, really. That's how you prevent burnout, or avoid burnout. Well, that's what I say, but I don't know how true that is. It's probably true for different people, but let me see. So, this is one of the papers I'm reading through. Imaging synaptic density, the next holy grail of neuroscience. So basically what I'm doing is... Okay, yes, I said I'm working at a neurology lab, but this is a project focused around fucking Alzheimer's research. So, yeah, so we're basically working with mouse models, which kind of translate to human models of Alzheimer's and dementia. But, yeah, let's see how this goes. I need to figure out, because I only have one paper up so far, but there is another one that I could bring up. Because for this particular paper, I'm not reading through the entire thing, it's just one section. I could do that. I could do that in the middle of the night. And the other one, it's kind of like a general overview, which shouldn't be too hard. So that's 2 papers. Sorry, I just fucking threw my pen across the room trying to explain all this. I'm using fucking hand gestures. You're not able to see what I'm doing with my hands at the moment. Not with this model, at least. But yeah, let's see. So I've got this paper up. Let me bring up the other one. Once I find out what the other one is. Do I even have it downloaded? I'm sure I have it downloaded. Literature. There we go, I found it. What's this one? The intersection of amyloid beta and tau synapses in Alzheimer's disease. So this is the one that I'm gonna have to do a general overview of, or bring myself to a general understanding of it. But I'm gonna tackle the easy one first, which is imaging synaptic density, the holy grail of neuroscience. Let's see. Let's read through the introduction first, so we know what the fuck we're dealing with. So, the brain is the central and most complex organ in the nervous system, comprising billions of neurons that constantly communicate through trillions of connections called synapses. Despite being formed mainly during prenatal and early postnatal development, synapses are continually refined and eliminated throughout life via complicated and hitherto incompletely understood mechanisms. So basically, there is a lot that we don't know about the brain. That is what it's essentially saying. Yes, I can totally agree with that. Failing to correctly regulate the numbers and distribution of synapses has been associated with many neurological and psychiatric disorders, including autism, epilepsy, Alzheimer's disease, and schizophrenia. Let me read through that again. Correctly regulate the numbers and distribution. Let me just highlight that for myself. Yes, that completely makes sense. Therefore, measurements of brain synaptic density, as well as early detection of synaptic dysfunction, are essential for understanding normal and abnormal brain development. Let's see. Detection and measurements of brain synaptic density, as well as detection and dysfunction. Let me read through that. I need to process this. Measurements of brain synaptic density, early detection, synaptic dysfunction. Detection of synaptic dysfunction, okay, are essential for understanding normal and abnormal brain development. To date, multiple synaptic density markers have been proposed and investigated in experimental models of brain disorders. Okay, I will highlight that for myself. I'm gonna write this on paper as well, besides from highlighting this. The majority of the gold standard methodologies, e.g. electron microscopy or immunohistochemistry, that's what I'm doing in the laboratory, visualize synapses or measure changes in pre- and post-synaptic proteins ex vivo. So ex vivo means afterlife, or, well, vivo is the Latin word for living or life. However, the invasive nature of these classic methodologies precludes their use in living organisms. Let's see. Yes, okay, because electron microscopy and immunohistochemistry are, you know, as the paper says, it's very invasive. That's why you cannot do that on living things. They have to be dead first. You need to kill them before you can collect samples and, you know, analyze them through electron microscopy or immunohistochemistry. The recent development of positron emission tomography, PET tracers, such as whatever the fuck this is, such as FUCBH or CEBGJ, this is new to me, I don't know what the fuck these are, but as far as I know, they are tracers. They are tracers, so basically they mark things in the body. They're like tags. It finds something, it tags it, and then you could see it when you analyze it. Let's see. That bind to a putative synaptic density marker. What the fuck does putative mean again? Putative. Let me fucking quickly look that up again. Let me look that up quickly. Putative definition. Commonly accepted or supposed. That's what putative means. So, let's see. That bind to commonly accepted synaptic density marker. The synaptic vesicle 2A protein, synaptic vesicle protein, is heralding a likely paradigm shift, detecting synaptic alterations in patients. Let's see. The synaptic vesicle 2A protein. It's heralding... Let's see, how much of this do I want to highlight for myself? I'm gonna just highlight this, in general. Let's see. Despite the limited specificity, novel, non-invasive magnetic resonance-based methods... Wait, hold on. Let me read that again. I didn't read that correctly. Despite the limited specificity, novel, non-invasive magnetic resonance-based methods also show promise in inferring synaptic information by linking to glutamate neurotransmission. Let's see. I need to read this a couple of times. Right. I'm gonna write it down. Non-invasive magnetic resonance-based methods also show promise in inferring synaptic information by linking to glutamate neurotransmission. So let's see. So essentially, you could deduce what synapses are doing by measuring glutamate levels, I guess, or the movement of glutamate. Glutamate is kind of like... it's an amino acid, because if you go to the kitchen, you might find monosodium glutamate. That is glutamate with a sodium ion attached to it. And basically, glutamate apparently works by, you know, it's also a neurotransmitter, so that's what neurons use to communicate with each other with. Okay, that's fine. I don't know how involved glutamate is, but that's what it is. It is involved somehow. Although promising, all these methods entail various advantages and limitations that must be addressed before becoming part of the routine clinical practice. Okay. I'll highlight that for myself. In this review, this is a summary, they're summarizing this. We summarize and discuss current ex vivo and in vivo methods of quantifying synaptic density. Okay. That's gonna be relevant to what I'm doing. So, let's see. I'm gonna do this. The annotation, fucking... I'll make this red so it stands out to me. Okay, that's a bit too red. That's red enough. Cool. Including an evaluation of the reliability and experimental utility, we conclude with a critical assessment of challenges that need to be overcome. Sorry, I am reading faster than my mind is processing this. In this review, we summarize and discuss current... Okay, that's fine. So by measuring synaptic density, you can evaluate the reliability and experimental utility, or whatever that means. We can conclude with a critical assessment of challenges that need to be overcome if we're successfully employing synaptic density biomarkers as diagnostic or prognostic tools in study. Hold on. I need to read the sentence a couple more times. We conclude with a critical assessment of challenges that need to be overcome for successfully... Right, so they are identifying challenges and limitations with these biomarkers. It's diagnostic tools. Okay. Right. I get this. I'm gonna highlight this for myself. Look, I'm not gonna pretend that I know what I'm doing. I'm just doing my best. I'm trying my best, and that's what matters. Good annotation. That's not what I want. Is it this? It's not this. What? Oh well. Highlighting this. Edit this. Oh, that's too blue. Why does Sumatra PDF make it so bright? Or, well, it's not bright, but it's really retina burning. Right. So that's the introduction out of the way, but the section I need to focus on in this paper is the histology and immunohistochemistry. So, while electron microscopy is arguably the best and most direct method to study synapses ex vivo... Hold on, I need to burp. Sorry, I had fried rice. Histology and IHC, histology and immunohistochemistry are the most common owing to their wide accessibility, ease of use, and lower cost. Okay? These techniques are employed with two main purposes: to evaluate the morphology and density of dendritic spines, present predominantly but not exclusively in excitatory synapses. Okay. Evaluate the morphology and density. Okay, I can highlight this. So let's see, let me just write this on paper first. Let me see the title of this first. Oh, what is this? What the fuck? Image of a cortical glutaminergic synapse of an adult. This mess of words here is basically the strain of mouse. It is probably genetically engineered or, selectively bred to have, to have certain properties. In my case, there's a line of mouse called L66, which is basically a mouse model which simulates Alzheimer's disease in humans. So basically, that mouse has been engineered to develop Alzheimer's disease later in life. So let's see. Images of team. That's not important right now. I need to figure out. Sorry, this is me getting distracted again. Dendritic spines. Cool. Presynaptic, postsynaptic neuron. Okay. What is this? In this box, you can have these. You can have high density, low density. Basically tree branches. Morphology, whatever the fuck this is. Okay, okay. Excitatory synapse, so that's the one that will be the postsynaptic, I believe. Inhibitory synapse. Uh-huh. Okay, cool. Riveting stuff. Just scroll the way up. So let's see. The date today is the 21st. It is still the 21st. It's not even midnight yet. I made a great start. 21st of fucking May 2024, I believe. So let's see. What should I write this? I'm writing on paper right now. I'll just write on the title of the paper first. Imaging synaptic density. And basically, I'm reading up on the immunohistochemistry. And it's written by... who the fuck is this? Serrano. So, M.E. Serrano et al. Et al just means and others. I think that's a Latin term, but that's what you use when you're in science, I guess. They really like to obfuscate things. Yeah, simple English doesn't really fly in this field, I guess. Well, I say I guess, but that's how it is. Okay. And basically, with this paper, I just need to understand the immunohistochemistry. Okay. So, histological quantification, that's what I'm going to be doing, so that's relevant to me. And this has been much of interest in blah blah blah. Sorry. Histological quantification of dendritic spine morphology and density has been of much interest in the study of normal and pathological brain conditions, due to the important role of these structures in most excitatory synapses. Okay. Let's see. Sorry, I'm just writing notes again. So, I'm not copying it directly, but I'm just putting in my own words. So that's what I'm trying to do right now. Histological quantification. Also, these notes are going to help me understand what the fuck my project's about. So basically, the way I understand my project is that I mentioned earlier there's a line of mice called the L66 line of mice that's been developed to develop guaranteed Alzheimer's later in life, but this particular strain that I'm going to be working with has been crossbred with another strain of mice with a different kind of mutation that apparently protects them from Alzheimer's. Right? Sorry, I'm just taking out my tea bag here. Right, my tea is still way too hot to drink. Dendritic spine morphology. Why am I getting deja vu all of a sudden? And density. Normal pathological brain conditions. This one is important in the study of normal and pathological brain conditions. Due to their role in excitatory synapses. Cool. Their involvement in synaptic plasticity, learning, and memory processes. Just running this again. And in synaptic plasticity, learning and memory processes. Jeez, my fucking synapses are fucking struggling. Processes. Cool. And the presence of abnormal spines. Abnormal spines in many brain disorders. As well as the presence of abnormal spines. Brain disorders. So let's see, the quantification of spines, the number of visible spines per micrometer of dendrite, is considered to represent an index of synaptic density and functionality. Due to the presence of these structures in most synapses, let's see, we're chipping away at this. Highlight that for myself. Quantification of spines per micrometer. Is representative of synaptic functionality. And density as an index. Okay, we're getting somewhere. Recent research has highlighted the existence of a bi-directional relationship between... What the fuck is this? Recent research has highlighted the existence of a bi-directional relationship between spine maturation, functionality, and synapse stability. I need to read this several more times. Give me a second. I'm only human. So let's see. So basically this is saying spine maturation and functionality is related to synapse stability. Okay, no, that makes sense. If a synapse is stable, then you know that affects the function and spine maturation. Okay, I can get that. I wish they said it much more simply. For example, it was reported that even subtle changes in spine structure or motility can affect synaptic transmission. Yeah, okay, yeah, if something's fucked up, it's not gonna work as well. Yes, that makes perfect sense. So let me make a quick note. Even... Jeez, I just took a hot shower and my balls are fucking... absolutely fucking sweltering. I even put fucking baby powder on. Fuck. Changes in spine structure. Spine structure. Or motility. Can greatly influence synaptic transmission. Cool. And that an increase in synaptic strength promotes the emergence and maturation of spines. Okay. Increased synaptic strength equals emergence and maturation of spines. Emergence, maturation of spines. Okay. Among the ex vivo, so outside of living things, if I'm interpreting that correctly, methods used to personalize changes of spine morphology. Golgi staining is oldest and most commonly used. Okay, Golgi staining. I know Golgi body from like, from like, I don't know, basic cell biology. But that's not what I'm focusing on. I don't think I'm doing Golgi, however you want to pronounce it, staining. This impregnation method, involves the accumulation of heavy metal ions, silver and mercury, on the surface of a small subset of neurons, allowing the visualization of their entire structure, including the dendritic spines. Since its inception, this method has been improved, modified to make it faster, the Golgi-Cox method, and even combined with other techniques such as electron microscopy or tissue clearing and fluorescence. Despite the relevance and utility of Golgi stainings. Despite the relevance and utility of Golgi staining, it also presents disadvantages such as random and unpredictable cell staining. Okay. Therefore, alternative methods have been developed, such as staining with the carbocyanin dye, DIL, that's not the dye I'm using, a fluorescent dye whose insertion into the lipid membrane of the neurons allows visualization of their architecture. Okay, no, I can totally visualize that in my head, that's fine. Or the use of Lucifer Yellow. You sometimes come across like some interesting names in this. Lucifer Yellow, or XFP, I think Lucifer Yellow, this color here, is extracted from fireflies, because I know fireflies have... I don't know if it's an enzyme or a protein, it's one of those things, called luciferin, and that's what gives it the light. And the word Lucifer, if you look into the meaning of the word Lucifer, it means the light bringer. Food for thought. Fluorescent proteins that label the entire neuronal structure. Hold on. I think I skipped ahead. Green GFP. Oh, green fluorescent protein. That comes from jellyfish. YFP, cyan. Don't know about that one. Don't know about red. But I'm not working with fluorescent proteins or fluorescent labels. I'm not working with those. All these techniques allow quantification of potential changes in spine morphology. And that's the. I don't know if this would be relevant in what I'm going to write for my report. What the fuck? 4D image reconstruction. What the fuck? What does a 4D image consist of? Is that like change over time? Either way, let me read through that again. All these techniques allow quantification of potential changes in spine morphology and density when combined with manual and automatic analysis of Hold on. Let me read through this a couple more times. So the use of fluorescent tags or, tags or proteins or labels allow quantification of potential changes in spine morphology and density when combined with manual and automatic analysis of maximum intensity reconstruction. So with these tags, they could find out what the spine looks like, what the spines look like, and how dense they are when you image them, like say under a microscope, for example, or electron microscopy. Okay, but that's not relevant to me. Moreover, the in vivo visualization of spine dynamics, so in vivo in living organisms. In vivo visualization of spine dynamics. So usually in vivo involves using zebrafish most of the time. You could use different animal models in the lab. Yeah, I'm just thinking about a lab I could have worked in. They would have worked on guinea pigs, for one thing. They also work on monkeys and dogs, but I never got hired there. I know some people who work there, and they don't like it. I had an old coworker who would say that. She was really put off by it. She worked there for a while, but she definitely mentioned like the look on the monkeys' faces, and she did not like that. She did not like that job at all. So she wasn't there for too long. But let's see. And, understandably so. I would be put off by that. I think anybody would be put off by that. But, science, that is the nature of the beast, I guess. Thanks to the combination of transgenic mice expressing genetically tagged fluorescent proteins such as... Oh, okay. Give me a second. Let's start this. Spine dynamics is possible in freely moving animals, thanks to the combination of transgenic mice and new microscopy methods. So, you don't need to kill the animal, because you can directly observe them, as they're living. Because these transgenic mice, basically genetically modified mice, they are expressing fluorescent proteins, so basically they are glowing in the dark. They are literally glowing in the dark. So they could either express this protein here, PSD95 GFP, or thymine 1 YFP. I think yellow, YFP stands for yellow fluorescent protein. I've never worked with it. I've worked with GFP, way back during like my vocational diploma time. This is a very long time ago. 13 years ago. I think it was 13 years ago. 14, possibly. Let's see. But that's not what I'm working with. Oh my god, there's more. Oh my god. There's several more chapters. Fuck. Right, I'm gonna spend all night on this fucking chapter. Fuck's sake. Immunohistochemistry, so I'm starting off from here. From the very top here. Immunohistochemistry, and particularly immunofluorescence, IF, which involves the use of a secondary antibody chemically conjugated to a fluorescent dye So I am using secondary antibodies. That's what I've been working with. Has been extensively used to evaluate changes in the expression of pre- and postsynaptic proteins as indices of synaptic density. It's too warm. It's too warm for me to concentrate. And my tea... Oh, my tea has cooled down a bit. I've made some oolong tea. Right, I think I'm gonna take a sip. Cheers, everybody. Ooh, yes. If only I had a snack with me. That'd be quite nice. Oh my god. I do have a tin of beans I could eat from. I could absolutely go for that. It's not too late for me to have a snack, actually, but let me finish reading this first, and then I'll see how it goes. So, I could kind of write a note on this. Pew-pew! No. Histo. Chemistry. Has been so used to evaluate changes in the expression of pre-post synaptic proteins. As indices, I think when they say indices in this case, they mean like indicators. So, let's see. So, immunohistochemistry has been extensively used to evaluate changes in the expression of pre-postsynaptic proteins as an indicator of synaptic density. Okay, I can fuck with this. One of the advantages of this technique is the possibility of differentiating between excitatory and inhibitory synapses, owing to the availability of multiple antibodies that target proteins predominantly expressed in these synapses. I don't know if I'm working with any of these proteins, but either way. Jesus Christ. Histochemistry has the advantage of possibly differentiating between excitatory inhibitory synapses. Thanks to the availability of Oh, antibodies. My god, I really need to stop crossing my legs. My balls are too fucking sweaty for this. Multiple antibodies that target proteins predominantly expressed in them. So, for example, excitatory synapses express PSD95, that's a protein, whereas inhibitory synapses express gefirin. I have never heard of these. That's fine. Such differentiation has been an important tool in the study of selective gains and losses of synapses in diseases, such as Alzheimer's disease. Oh my goodness, that's something relevant. Differentiation of targets are for study gains and of disease such as Alzheimer's disease. Okay. Oh. Moreover, the ability to distinguish between synaptic proteins has also led to the discovery that PSD95 and neuroligin, I'm gonna say neurologen 1, are one of the key regulators of the ratio between the number of excitatory and inhibitory synapses in the brain, the imbalance of which has been hypothesized as an underpinning factor of some brain disorders. Is this relevant to me? Oh shit. Oh fuck. But either way, I can make a footnote of this. Oh my god. So let's see. Excitatory synapse protein PSD95. So was this PSD95 Photoshop D PSD95 and Neurologen 1 are key regulators of the ratio. The number of excitatory inhibitory Synapses in the brain. The imbalance of which has been hypothesized as an underpinning factor of some brain disorders. Let's see. Balance of which are possible underpinning factors. Of some brain disorders. Of some brain disorders. Cool. In contrast, most presynaptic proteins, including SV2A and synaptophysin, are expressed in both excitatory and inhibitory synapses, allowing a global quantification of synaptic density. Okay. Let's see. Presynaptic proteins such as SV2A and synaptophysin are present in excitatory, inhibitory synapses, allowing for global quantification. Synaptic density. Okay. I think I'll take a break after this fucking chapter. Alright, what the fuck is this? I think my supervisor mentioned a table somewhere. There's a table mentioned here, I should probably take a look at that. Sorry, I'm clicking my pen too much. I'm having too much fun doing that. Right. Such quantification is mostly performed by first applying a background correction and then analyzing the distribution of a number or intensity of the immunoreactive. What the fuck is it? What the fuck is a puncta? What the hell is a puncta? Let me quickly Google this. I heard Google's been going to shit lately. Copy selection. Let's see. Ugh. Let's see. What the fuck? No, nothing is explaining what the fuck a puncta is. What the fuck is a puncta? Oh well, that's a question for my supervisor, I guess. Oh, it's past midnight here. background correction, and analyzing distribution. Such quantification is mostly performed by applying background correction and then analyzing the distribution. Ah, fuck's sake. Actually, in a second, what is a puncta again? Maybe I'm not searching correctly. So I was looking up immunoreactive puncta, but what if I just looked up puncta? Tears drain into openings called puncta. Okay. So puncta is like an opening. Okay, I see. Okay. Right. Yes. Okay. Sorry, I'm just trying to pick up where I left off. The distribution number or intensity of immunoreactive puncta. I guess you could also call it a duct, D-U-C-T. I would more easily understand that instead of puncta. If they said duct instead of puncta. Or evaluating the mean fluorescence intensity within a region. Hold on. Or evaluating the mean fluorescence intensity. Within a region. Okay, that's that fucking chapter finished. What the fuck is this? Histology and preclinical research. Let me just skim through this quickly. What the fuck are these? A bassoon protein. What the fuck is bassoon protein? Role in synapse. Assembly and organization of active zone in with Piccolo. With fucking Piccolo. What the hell is this? Present these. I don't know what fucking proteins I'm working with. All I'm doing is fucking staining. Ugh. Localization. Okay. Vesicle active zone. Vesicle fusion machinery. That sounds rather fucking high tech. Adhesion scaffold. I might be working with scaffolds because I'm working with microtubules. They do mention microtubules a bit. Hold on, this relates to something previous. Up here. Oh, excuse me. Histological examination of synapses in clinical research has hitherto... Who fucking says hitherto? Has hitherto contributed to many important scientific discoveries in animal models of different brain disorders. As an example, abnormal spine morphology, density, and function have been related to cognitive deficits and important in neurodevelopmental disorders such as Down syndrome and autism. I wish this wasn't chopped off. Abnormal spine morphology are related to cognitive deficits such as Down syndrome or autism. So basically, if you have a fucked up spine, you're fucked. For instance, the TS65DN mouse model of Down syndrome exhibits a decrease in spine density, but an enlargement of these structures. So, less dense, but also larger, so it's kind of like spread thin. Okay. Which seems to correlate with the severity of cognitive impairment. Okay. In autism models. I wonder what they use as an autism model. In genes coding for postsynaptic proteins such as SHANK3. Oh my god, this is exciting stuff. So on modification of dendritic spine morphology, suggesting a relationship between synaptic protein expression and spine morphology. Fuck, this is going way over my head. In genes coding for... Okay. Result in modifications. So, if you have a fucked up gene, which produces a fucked up protein, it will produce a fucked up dendritic spines. Okay, that makes sense to me. Suggesting a relationship between synaptic protein expression and spine morphology. Okay. However, not all the alterations in dendritic spines and synaptic protein concentrations are associated with genetic factors. Some of them are the result of internal changes, such as the alterations in proteins, learning processes, or environmental changes such as stress and isolation. Oh god, I'm at risk. Therefore, changes in spine density. Jeez, hold on. Let me check my spine posture. Ugh, fuck. And isolation, therefore, blah blah blah, and the concentration of different pre- and post-synaptic proteins have been extensively studied as markers and potential therapeutic targets for diverse pathologies and disorders. I'll highlight that for myself. Oh my god, I can skip all this. Because... No, take me back. Epilepsy, Alzheimer's disease. There we go. This is what I want. Hold on, let me get off my chair for a second. Because it is warm, and I just had a hot shower, I'm absolutely fucking... I fucking swamp passed. That's what I'm trying to say. Histology and neuropsychiatric disorders, I don't care about that. So, let's see. I should probably take a short break. I need to fuck about for a bit. Otherwise, like I said, my brain's gonna go fucking numb. I will. It's the middle of the night. How can I kill time in the middle of the night? I sometimes find myself playing chess. I know it's like an absolute fedora fucking activity, but, you know, who's gonna play with me? I'm gonna play against the computer. Let's see. bring up the window. That's not what I want. Right. I'm gonna bring up a new window capture, and hopefully there isn't something that's gonna goatsy everyone. Okay. Brought up the window capture. Let's see. Chess online against computer. Okay. There's nothing doxable here. That's fine. We're off to a great start. Excellent. Let's see if we can adjust this. Crop pad. Taking a break. I'm taking a break about fucking... taking a break from reading neurology papers by playing fucking chess. Jesus fucking Christ. What have I become? It's fucking... Look at the fucking state of me. This is what I've been reduced to. Sorry, I'm still cropping here. Okay, and then 220 to the left. How much do I want to crop off the right? 120? Okay, maybe 180. Okay, maybe 220? Getting closer. 250. Let's try 300. Okay. 350. Sorry, this is my OCD here at play. I'm actually self-diagnosed actually. Because who knows me better than myself? 3, 4, 5, 6, 7, 8, 9, 10. Right, I've cropped it to by a factor of 369. Right, let's get to this. Hold on, let me do one more thing. Filter. Image mask. Yes, please. And where is it? Where is it? I have it somewhere. Bear with me for a second. Where is it? It's not this. It's not this either. Oh, I found it. There we go. I need the wiggly border. You don't get it. I need the wiggly border to function. Right. Color channel? Alpha channel, more like. Thank you very much. Right. Right, it's completely fucked with my cropping. Sorry, this is... I need everything to be perfect, okay? Oh. Oh, this is actually fine. I can fuck with this. I can absolutely... Okay, maybe not fuck with this, because the entire left side has been fucking chopped off. Ugh. I mean, you don't need to see the entire board, do you? Right, we're going into the fucking negative numbers. Uh-huh. That's not the entire board. 500? Okay. Okay. We're getting somewhere. 100. Okay. Okay. 50. 0. Okay. Uh-huh. Yes. Nothing like taking a break from the intellectual pursuit of science. Like playing fucking chess. Right, anyway. No, it's still not right. Sorry. Still tweaking a few things, but who cares? Who's watching? 450. What the fuck is going on here? You know what? Fuck this. Fuck the mask. I'm sick of it. Sorry, I keep fucking about with this, when I really shouldn't. 200. Right. Is this doxing me, by any chance? Okay, I'm a guest. The thing identifies me as a guest. That's fine. Right. This is taking an awful long time just to play a fucking game of chess. 400. Okay. Okay, we're fine. We can get fucking started. Right, anyway. This bitch here has been kicking my ass this entire time. I've been playing against her for months, but she always fucking beats me. But I think I have figured out her tactics here. Right. I think I have sussed her out, but let's see. I did get pretty close one time. I say one time, I mean like the other day. That's how recent it is. After like several months. Ni hao. Don't be mad when I win, Kay. I'm gonna be so fucking mad. Is there another opening for an aggressive player? I don't know. Do I care? I could... Fuck this. I need to play defensively against her. So what I'm trying to do is possibly bait her if I can. Okay. Back onto my seat. It's getting serious. Right, what the fuck is this? Let's make this quick. I think not. I'm gonna take my fucking time here. Do something! So she can go either way. That's fine, I guess. What's she gonna do? Oh fuck. Right, she's trying to fucking lure me here. This hussy here. Because if I take that bishop, that knight's gonna fuck me up. If I take that knight, that pawn's gonna fuck me up. I'm fucked either way. Unless I do this. Where's she going with this? Put this pawn here. What are you gonna do? Oh, I see. Right, I need to block this guy off. I think. Unless she's like laid a trap out for me. Which would be absolutely fucking awful. I'd be a bit miffed if that was the case. I see. I figured it out. I have you absolutely figured out. I have absolutely read you like a fucking book. Except that book has fucking War and Peace. Fuck. If I take that pawn, that queen's gonna fuck me up. What if I... I'm gonna ponder this over some tea. I'm gonna take a sip. Cheers everybody. I've been smoking cigarettes so much lately, I need to try not to fucking inhale my fucking tea. And fucking drown myself. That's happened a few times. I've been fucking Pavloved into it. I see, yes. Doesn't get it at all. Fuck. What if I did this? Yeah, you fucking run away. How am I gonna do this? What the fuck do I do? This horse could potentially go either here or wherever, where the fuck it likes really. If I go here, so I'm trying to visualize the possible consequences. Oh god. I could do takebacks though. Oh shit. She's gonna try something. She's up to something. I just know it. This fucking hussy is up to something. She might try and play me like a fucking fiddle. Oh fuck. Might do a queen move. I don't know, that's what I'm thinking. Guys, help me out. Fuck. Actually, don't help me out. I need to do this myself. I need to figure this out on my own. I need to do shit myself. I wouldn't mind playing another game, but it's just that my laptop can't fucking do much. I haven't played War Thunder in ages. I miss playing War Thunder as much as I hate it. It's one of the few games that I get sweaty at, or get sweaty over these days. That game has me by the balls for like over 10 years. It's not even funny. I'm gonna do this. I might do something very stupid. That's not what I thought. That's not what I wanted. What if I did this? What are you gonna do? So that's how it is. I see what you're up to. I see the game you're trying to play. Just gonna go either here, or the fuck. That's a fucking check. That's a fucking checkmate. Yes! There we go. I knocked her down a peg, but I need to make a retreat. I need to make my escape here. I've showed off too much. I have shown off too much. I need to get this fucking bishop back to safety. That was my little scare tactic there, and I'm sure she's quite impressed. I'm sure you're all impressed too. What the fuck is she? What the fuck is this formation? Oh fuck. Am I doing something with my horses here? I don't know. I'm trying to play defensively here though. Horsey can go there. Horse can go there. Potentially here, or here. And either way, these two are covered by that bishop there. I need to do something about that cunt. That fucking bishop is just sitting there, acting all smug. I think he's all that. Fuck, what do I do? At least there's no time limit for this. I'm gonna think over this. Give me a second. I'm gonna take a sip. Cheers, everybody. Right. I'm gonna tackle this. Pewee. Ugh. I'm just thinking about that League player who got really good at chess out of spite. That guy's fucking funny. With all due respect, that guy's funny. This is out of bounds for my bishop here. All these black squares here. In the diagonal. I could put my horse here, but that would fuck everything up. I could put my horse here though. Oh! No, no, no. I want to take back. I want to take back. No, you can't do this to me. Oh my god. I didn't see that. She caught me with my fucking pants down. Oh no. She's gonna do something. She's gonna do something absolutely fucked. I hate this. Oh no. She's styling on me. She's gonna dab on me. I just know it. Please, no. But I'm just evaluating something. I'm just running a few calculations in my head. A bit of triangulation as well. Fuck. Do this. I can do this. I know I can. I need to do something about my queen. My queen is rather vulnerable. She's not in a good spot. No, she isn't. I could do this. And I might be able to dab on her if I play my cards right. Shoujo, shoujo. I'm gonna put my horse here. Ooh, no. I see what she's trying to do. She's gonna be very cheeky, and I don't like it. I see. Oh, there's a king here. What are you gonna do? Oh, fuck. So that's how it is. I think I might commit to this. I'm gonna sleep in the bed that I've made for myself. Ooh. Ooh. Rookie mistake. Huh. I'm gonna do this. I need to get my queen out of the situation. I could go here or here. It's one of these. I'm not sure which one. Either F6 or F8. No. G6 or F8. I mean. Oh, fuck. Oh fuck. It's gonna be so dog shit, I just know it. Move my horse up here. Ooh, what you gonna do now? Huh? Huh? Try this. I hope I don't regret this. Ah! It's not what I want. How? How am I gonna do this? Or I might be able to live with that, to be honest. Because I could just take that. Fine. Ooh, I took your queen. Fuck! That hussy, that absolute fucking hussy. Can't believe she's done this. Fuck. She's got me by the fucking balls. Fuck. God damn it. No. She's gonna do it. I knew it. Fucking knew it. She's fucking squeezing my balls here. Fuck. This is awful. She's squeezing them like fucking boiled grapes. Fuck. My god. Shoujo. I need my horse guy to do something. Because what if I did this? What if? No. What if I didn't? I need to get my horse guy out of the situation. Fuck off. Fuck right off. got a fucking defensive wall going on. That's absolutely fucked. Don't like it. Don't like it one bit. Oh fuck. Oh fuck, I fucking screwed up. This is so dog shit. What now? Can't believe you've done this to me. Prick. Fucking shitebag. You fucking... Yeah, whatever, I don't care. I threw this on purpose. Let's see, how badly did I fuck up? This game assesses how badly I fucked up. 0 blunders, 3 mistakes, that is not bad. I've done a lot worse. Okay, I can live with that. Fine. Cool. I'm done with this. I'm done with my break. Gonna close that. Get rid of that. And I'll read that one chapter and then I'll wrap up the stream. Because I need my beauty sleep and I gotta be in the lab tomorrow. What the fuck was I doing? I was reading a paper, I'm pretty sure. I believe it was this paper, if I'm not mistaken. Okay. Right. I'm gonna highlight this for myself. Can I highlight chapters here? No. I'll do this. What color do I want it to be? Do I want it navy? Excuse me. Or perhaps red? To invoke a sense of urgency. I'm gonna go with red. I do like red. Red's my favorite color. Okay. Histology and immunohistochemistry in animal models of Alzheimer's disease. Changes in the morphology and density of dendritic spines have been postulated as main reasons for the synaptic and neuronal loss observed in AD, Alzheimer's disease. So, let's see, I probably need another page, but I'll finish off this page that I'm writing on. Hold on. I need a different colored pen, otherwise I'm just reading a wall of text that's all black, and I'm just gonna space out. Right. Changes in morphology and density of dendritic spines. Dendritic spines have been... Sorry, I miswrote that. Have been postulated. Oh no, I think I'm running out of ink. It's my favorite pen too. I'm heartbroken. Have been postulated, that is a fancy name of saying propose. Like, I propose a point, I propose this idea. What the fuck is going on with this paper? Give me a second. No, I didn't run out of ink, it's just that this paper's fucked. Postulated. Postulated as main reasons 4 synaptic and neuronal loss. 4 synaptic and neuronal loss. Wow, isn't that just lovely? Seen in Alzheimer's disease AD. Therefore, dendritic spines are promising targets for new treatments. May possibly be new targets. For treatment. Pathological extracellular deposits of amyloid beta Q, well, amyloid beta, that's what I'm studying, protein or amyloid beta plaques, seem to have a major role in the aberrant spine morphology. Let's see, and decrease in spine density observed in Alzheimer's disease models. Right, highlight that. So amyloid beta. So that's like a kind of protein that's observed in Alzheimer's disease. They kind of like bunch up and fuck everything up, which they shouldn't do. Plaques. I wrote it down as plagues. I wrote it as a G instead of a Q. Plaques have an observable role. That's what I'm going to write down. Observed role in aberrant. I think that's a fancy way of I think that's a fancy way of saying fucked up. Aberrant equals fucked up. There. Hold on. I wrote that. I spelled that completely wrong, even though it was written out in front of me. Ah, and I still need to write my other 2 papers at the same time. Ugh. Aberrant spine. Hold on. Aberrant spine morphology and decreased spine density. Spine density. In Alzheimer's disease models. Interestingly, heavy quotations, amyloid plaques were associated with elevated activity of calcineurin, which affects the morphology and density of dendritic spines through the inhibition of wherever the fuck this is, peptidyl prolyl isomerase pin 1 signaling. What the fuck is this? What the fuck are you throwing at me? Alright, how am I gonna word this? Switch back to this pen. Amyloid beta plaques are associated with elevated calcineurin activity. I sometimes feel like they write these out to like stretch out the fucking word count sometimes. Calcineurin activity affecting morphology and density of dendritic spines. Of dendritic spines by inhibiting PPI. I don't know if I should write down the whole name of that thing. Yeah, that's just my hand's just gonna hurt. Peptidylprolyl. Fine, I'll write out the whole thing. Peptidylprolyl isomerase. Ugh. So basically, isomerase is an enzyme that changes the structure of a molecule. It will have the same chemical formula, but the structure will be slightly different. It's like an... well, that's what an isomer is, if I remember correctly from chemistry classes from way back. So, same molecule, different structure. I think. Pin 1. Signaling. I'm in pain. This led to O'Neill et al. 2018 suggesting that an FDA-approved calcineurin inhibitor be tested in Alzheimer's disease patients. However, sorry, I'm just batting my pen against my chest. However, evidence from the mouse model of Alzheimer's disease suggests that early decreases in spine density correlate. Early decreases in spine density correlate with cognitive impairment and emerge before any measurable accumulation of insoluble amyloid protein. Right. Let's see. So amyloid plaques are associated with the activity of calcineurin. Okay, that's fine. But which in turn affects the spines, dendritic spines, by affecting the signaling. Okay. However, evidence from this particular mouse model suggests that early decreases in spine density correlate with cognitive impairment and emerge before any... Okay. So, while amyloid plaques affect dendritic spines and whatnot, and, you know, affecting cell signaling or, you know, neuron signaling in a different mouse model, this happens early on, way before these plaques even appear or even able to be measured. Okay. Measurements of pre- and post-synaptic proteins have also been used as markers of synaptic density in Alzheimer's disease. God. It's almost over. Don't you worry. Measurements of pre- and post-synaptic proteins have also been used as markers of synaptic density in Alzheimer's disease models. Such investigations led to the discovery in the 2xTG. Alright, I'm not using that mouse model at all. Of an association between reduced SV2A and gefyrin in a nucleus. What the fuck is this? I think that's a part of the brain. In the lab, if you work in like a neurology lab or a lab that works with like mice brains, you'll get specialized books that map out, you know, the different structures of the brains or different parts of the brain. It's literally like looking at a fucking map sometimes. I'll try and get a picture sometime. Yeah, it's literally an atlas of a mouse brain. But I don't feel like bringing it up on stream right now. Ugh. Oh, that's so stupid. Sorry, let me read that again before I get distracted by this yawn. Measurements of pre- and post-synaptic proteins have also been used as markers of synaptic density in Alzheimer's disease models, such investigations such as discovery in the 2xTG mouse of an associate. This isn't making any sense to me. I need to read this several times. Have been used as markers. Also synaptic density. Yes, okay, that part makes sense. Of an association between reduced SV2A and confinement in the nucleus accumbens. Increase intracellular. Oh my god! I found a typo. Accumulation and increased glycine. It's alright. Oh, I forgive him. I can forgive him for this. And decreased glycinergic inhibitory manager. I might need to read that part several times. Measurement. I need a snack. That's what I need. I can't think on an empty stomach. Increase intracellular accumulation and decrease glycinergic miniature synaptic counts. Is there anything else? I think that's fine, to be honest. I already wrote a page of notes already. I think I can live with that. I can live with myself. I did some work. Is it worth doing a raid? I should probably do a raid. It's been fucking forever since I've done one. Let's see. I'm gonna wrap up the stream. I think that's enough studying for one night. Let me check something. Let's see. Shoujo. Oh my god. No, don't listen, don't listen, don't listen. Yeah, cool. Right. I'll raid into Enigmas. Funny enough, I mentioned Enigmas because I created his avatar, but yeah. Cool. Either way, I'm done here. Take it easy. Until next time, take it easy and good night. And I don't know, hopefully it won't be too long until I stream again. But yeah. Let's see, give me a second. Jeez, this university network. I think I can wait for the ad. I fucking hate ads on Twitch. You can't even skip them, that's absolutely fucked. And they always come in at the worst times. Like, I know they have to make money somehow, but it's still kinda fucked. Still kinda fucked if I do say so myself. Right, cool. Right. See ya!